order to show you the procedure, right?
But 1765 is good for most cameras.
Yeah, it doesn't have to do with the camera. The percentage of overlap.
Yes.
Well, if you have GoPro and it's fisheye, you can
Exactly.
use larger overlap.
That's why I asked.
Yeah, because you should overlap the fisheye effect.
Yes.
But some software can handle fisheye. So you can use regular overlap, but you have a wider field of view and you can take advantage of it by having bigger side lap, right? But the frontal overlap, I advise you to set in order to have pictures every 2.5 or 3 seconds. So I'm going to set the flight speed and I'm going to monitor photo every, now it's 2.5 seconds, right? If I increase the frontal overlap,
It will be more.
it will be less, so the pictures will be faster, right? The frontal overlap being less, the picture will be faster. At 2.2 seconds, the camera doesn't do it, skips. So you should be safe at 2.5, right? So you're gonna do frontal overlap at 70% with this camera, right? With the camera that is set here.
What about the speed of the card inside the camera?
You should use class 10 cards, class 10 speed class cards, because but it's not the writing time that takes time, is the compression of the JPEG inside the camera. Okay, so camera takes a raw image, which is huge, about 20 megabytes, and then compress it. This takes time, compressing, not saving.
Okay.
So having a huge speed card doesn't help much. Okay. So here is the angle of the mission, and I wanted to show you the most important thing is the heading hold of the copter. This is the heading of the copter to be hold all the mission. If you don't want the copter to face the next waypoint to lose time, then you can heading hold at degrees, let's say 90 degrees.
Heading to waypoint 1, altitude is 1, ground speed is 0.
And the copter, this is 0 degrees, this is 90 degrees, right? The copter will face this position all the time, right? So it will be faster. Going back to simple, I'm rechecking flight time estimate. This will be ideal flight time. Your flight time will be more because this doesn't include takeoff and landing, and also doesn't include corners. Okay? So let's say we have to be here less than 12 or 15 minutes. 15 minutes stop. Let's say 10, 12 minutes, right? So we're gonna click OK now. I don't have a home altitude because I didn't enable the copter, I didn't arm the copter. I would say home altitude is 50 meters.
Heading to waypoint 1,
So I
altitude
have
is
the
1,
mission,
ground
right?
speed is 0.
The first waypoint, let's check the waypoints for a second. The first waypoint is takeoff, then is setting the heading at 90 degrees, right? Then is the first waypoint at 60 meters. Then it starts triggering pictures, keeps the heading at the corner, waypoint again, that's next waypoint, then turns, this stops the camera. The camera is triggered every X meters. In our case, 6. 9. You should go, but it doesn't.
Heading to waypoint 1, altitude is 1, ground speed
It's like
is 0.
10 meters, 11 meters. The camera is triggered every 11 meters. But the camera should be triggered only on lines. So when it reaches corner waypoint until it goes to the next, it stops. This commands here with 0, it says don't trigger anymore until you reach the next waypoint when you should start trigger again. Okay? And you trigger on the right line, on the long line, then stop, trigger again, stop, trigger again. Okay? All the triggering commands are stored in the log. Then you must take it out to send it together with the pictures. So they geotag the pictures. And after the mission is done, you will see a return to launch command and the land perhaps, or just a return to launch command, because land is default when return to launch. When it reaches the top of the home position, it lands automatically. Okay?
And you set the altitude to 50 meters, so
I set the home altitude to 50 meters because you must have a home altitude when you write the waypoints. But if you arm the copter before you make the mission, then you have home position stored. Okay. There is also an important
it stays at
parameter.
50 meters.
There is an important parameter, the return to launch altitude.
Heading to waypoint
You can
1.
set it,
Altitude is 1.
and
Ground speed
the
is
return
0.
to launch altitude is a minimum altitude that the return to launch command should be issued. If your altitude, current altitude, is lower than return to launch, the copter before heading home will climb to that altitude and then come home. Okay? So the return to launch altitude must be set at, let's say, 20 meters. So if the copter is 50 meters, when the return to launch issue is launched, it will keep 50 meters. But if it's 15, it will climb and then come back. Okay? The return to launch altitude you can find in full parameter list. You search for RTL.
Heading to waypoint 1. Altitude is 1. Ground speed is 0.
Return to launch altitude, right? RTL alt, it's 3000 centimeters, which is 30 meter right now. Okay? So it's set fine, let's say. So if you're going on manual over there on the field and you're at 10 meters, if you trigger return to launch, you won't risk going into that tree because it will climb first to 30 meters and then come home, you know. That's about it. It's not very simple. But okay, after you plan the mission, you should write the waypoint into the copter using this button here. Using this button.
Save waypoint.
Heading to waypoint 1. Altitude is 1. Ground speed is 0.
E deconectat acum.
Nu e deconectat. Save waypoint file.
Heading to waypoint 1. Altitude is 1. Ground speed is 0.
Should try to restart it.